This lesson is going to be about kinetic energy relationships, and the learning target is to be able to explain the relationship between mass, speed, and the kinetic energy of an object. So let's pretend that we're back in like the 19, wait, no, not the 19s. We would be back in like the, I don't know, 1500s, 1400s when they use catapults on, whenever they use catapults on castles, whatever time period. I'm not a history teacher. This isn't a history lesson. If you're here for history, you're on the wrong lesson. So let's pretend that we're back in the 1000th years, sometime when they were trying to storm castles with catapults. And we got this guy here who's running the catapult. He's in charge of making sure these walls come down. And his boss is sitting up here on top of a horse. Now his boss is kind of upset because they've been standing here for a while and they can't figure out how to get these walls down. And so this guy here is a little bit worried about losing his job. So he's got to start trying some stuff out to get these walls down in this catapult. Now, he finally got all these rocks. He didn't have them for a while, but after all of his tests, he finally decided, well, I got to get some boulders. But the first thing that he tried was he tried this little cauldron thing right here. They just started lighting it on fire, but before he wasn't doing that. So he tried this little cauldron. Thing is, that cauldron has a pretty low mass. There's not a whole lot of mass to that thing. And so when he shoots it at the castle walls, nothing happens. There's really no change, right, to the castle walls. So what he decides to do is this is when he decides to go get these rocks. And so he brings out these rocks, loads a boulder up into that catapult because that has an increased mass. We've got that increased mass. And so when he shoots this at the castle walls, finally he has something to show his boss. There is some change. Right? There's some sort of change that happens. It's because this boulder now has more mass, so it can ram into those castle walls, and it's going to cause them to fall down a little bit more than this little boulder does because now they got some oomph with their shots here. And so the next thing that he thinks about, his boss looks back at him and goes, well, that's it. And so the next thing he thinks about doing is he looks down at this catapult and he sees this little ropes right here. So he's trying to figure out a way to tighten this up. He gets his buddy to come over here, and they go and they tighten up these ropes so that the catapult's got a little more spring to it. And so when he shoots this boulder into the castle walls, what happens is the castle, or the boulder, is moving pretty fast. It has an increased velocity. It's moving a lot faster. And so when he does that, though, this was kind of the big changing point for him in the moment when he kept his job, is when he increased the velocity of this thing, there was a lot of change. I mean, that boulder just smashed right through the castle walls. What he was really doing here when he was testing out how to get these castle walls to fall down was he was trying to figure out how to give the most kinetic energy to this boulder so that he could cause change. Because remember, energy is the ability to cause change. If we have more energy in whatever he's firing out of that catapult, he is going to be able to change those castle walls even more. The ways that he was able to do it was by adding more mass to whatever he's shooting out of that catapult. And the way that he was really able to do it, that had a huge effect on it, was for him to be able to increase the velocity of whatever he's shooting. If he can shoot this boulder out faster, it's going to cause a ton of change in those castle walls. And those are the different variables that affect kinetic energy and how they affect them. So as we're looking at kinetic energy from more of like a science perspective and thinking about how these different variables affect kinetic energy, it's exactly what we saw in the catapult. Kinetic energy depends on the mass and the velocity of the objects. And as we increase the mass, we have more kinetic energy. Right? And as we increase the velocity, as things are moving faster, we also have an increase in kinetic energy. But the cool thing about this is that the velocity affects the kinetic energy more than the mass does. And so we could almost think of this as like a double. You're going to be learning in the next lesson that it's a little bit more complicated than just double of the kinetic energy, because kinetic energy equals 1/2 mv squared. This is the equation that we're going to go over for kinetic energy. And so you can see that if we doubled the velocity, right, it's actually going to get squared. Whatever we change it by is going to get squared, so it will go by 4 times. If we quadrupled the velocity, the kinetic energy is going to go up by 16 times. If we multiply the velocity by 8, the kinetic energy is going to go up by 64 times. And so it's going to be a huge difference. All I need you to remember out of this lesson is that as we increase mass, we have an increase in kinetic energy. And as we increase velocity, we have an increase in kinetic energy. And as we increase the velocity, it affects the kinetic energy more. And the other thing to think about that is that just remember that as we decrease the mass, the opposite is true of the kinetic energy. We decrease the kinetic energy. And if we decrease the velocity, make something moving slower, we decrease the kinetic energy. And so that makes sense because remember, kinetic energy is the energy of motion. And so if we are not moving, we have a zero velocity, we do not have any kinetic energy. And so remembering this relationship is what we need to have for this learning target. So I hope this has helped you to understand the relationship between mass, velocity, and the kinetic energy of an object.